Dear students, today we will discuss the structure of nitric oxide molecule which form complexes with the transition metal atoms like that of carbon monoxide. The structure can be discussed starting from the molecular formula of nitric oxide. And the molecular formula of nitric oxide is NO. One N and one oxygen atom is involved in the formation of NO. It means the molecule NO is formed by the chemical combination of nitrogen and oxygen. And the atomic number of both nitrogen and oxygen are given here. Nitrogen 7, oxygen 8, and the electronic configuration shows that nitrogen has 5 electrons in valence shell orbitals, and the atomic number of oxygen is 8, and it contains 6 electrons in the valence shell. Valence shell is second shell here. Now count the total atomic orbitals, 3, 4 and again 4. 1s 2 belongs to K shell. This again belongs to K shell. So K remain inert during the formation of NO. Here total atomic orbital involved are 8, 4 and 4, 8. So 8 molecular orbitals must be produced according to molecular orbital theory. It is clear that 8 atomic orbitals and 11 electrons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 electrons are involved in the formation of NO molecule. The interaction of 8 atomic orbitals produce 8 molecular orbitals. 4 are bonding molecular orbitals and the other 4 are anti-bonding molecular orbitals. The bonding molecular orbital have less energy as compared to anti-bonding molecular orbitals. Less energy, bonding, more energy, anti-bonding molecular orbital. The bonding molecular orbitals are represented by sigma, pi, and anti-bonding by sigma star and pi star. And the filling of electron in molecular orbitals is done on the basis of Above principle, Pauli's exclusion principle, and Hund's rule. Above principle tells that the filling of electron in orbital must be done from low energy to high energy. Pauli's explain that 2 electrons in an orbital always have opposite spin. It is clear that total 11 electrons are contributed for the formation of NO. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And these 11 electrons are contributed by the both atoms. Both means nitrogen and oxygen atoms. The molecular orbital energy diagram for the formation of NO can be drawn as here the energy. Atomic orbital belonging to nitrogen, atomic orbitals belonging to oxygen, and formation of NO. These are the molecular orbitals. Here are the molecular orbitals. These are the atomic orbitals. The interaction of 2s give 2 molecular orbital. Sigma 2s, sigma star 2s. It is bonding molecular orbital. It is anti-bonding molecular orbital. Interaction of px give 2 molecular orbitals, sigma p2px, sigma star 2px. And yz 4 atomic orbital interact to form 4 molecular orbital, pi 2py, pi 2pz bonding, and pi star 2py, pi star 2pz anti-bonding. The filling of electron is done according to the Above principle, Pauli's exclusion principle, and is shown here. Total electrons are there 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and single electron 11. It means NO has unpaired electrons, so it must be paramagnetic in nature. Now, the formation of NO can also be shown as NO-KK, means KK. The first shell in both cases, nitrogen and oxygen, remain inert during the formation of NO. And now, write the molecular orbitals along with electrons by seeing the molecular orbital energy diagram. Sigma 2s2, check there. Sigma star 2s2, sigma 2px2, pi 2py2, pi 2pz2, and pi star 2py or pi star 2pz contains one electron. The bond order of NO molecule can be calculated by the formula, the same formula which was used in case of carbon monoxide: bond order, number of electron in bonding molecular orbital minus number of electron in anti-bonding molecular orbital divided by 2. So 8 in bonding, 2, 4, 6, 8, and 2 and 1, 3 anti-bonding. 8 minus 3 divided by 2, 5 by 2. It means how many bonds are there? 2.5. It means 3 bonds are present in NO molecule, and these bonds are 2 covalent bonds, and the third bond is formed by 3 electrons. 2 are contributed by oxygen and 1 by nitrogen. 2 bonds are covalent and 1 is with 3 electrons. See again, the structure well accounts for the lower bond strength and longer bond length as compared to N2 molecule. It means the bond length of NO is longer as compared to nitrogen. Thank you very much. This NO will act as ligands in the nitrosyls, which are the complexes which will be discussed in next lectures. Thank you very much.